Hello all. Today we are going to be choosing the best measure of central tendency. So for any data set, you can perform the analysis to come up with a value for each variable. You can perform any of the ones from yesterday, the mean, median, and mode. However, there are a few basic guidelines to help you choose the most appropriate form of finding our central tendency to describe our data. So for a normal random distribution of data, evenly distributed, the mean is preferred. So what we're talking about is something that looks like this. This is more of like an actual statistics class. You could take a whole semester class all about this stuff. This is called a bell curve or a normal distribution. We won't see much of those curves, but we will look at something called a box plot. And when you're looking at the box plot, if it is normal, your whiskers will be about the same length, okay? This is compared to a skewed data set in which the median is more appropriate than the mean to use. The skewed data set has extreme data points and will cause the mean value to be much more extreme than the median and therefore less central. So for example, when my husband was looking for engagement rings, you can look up what the mean cost of engagement ring is, and it was crazy expensive. I don't exactly remember what it was, but for this example, say it was around $12,000, okay? Now, I could not imagine spending nearly that much on a ring. And the reason the mean was like that is because there's people out there paying millions of dollars for an engagement ring, while other people are only paying a couple thousand or even a couple $100, okay? So those people that paid millions of dollars for that ring really skewed the data, while the median would show, if you look that up, say it's closer to like 2,000 or 3,000, that the median amount of people, so like half the people spend more than that amount and half the people spend less, is about 2,000 to 3,000. Now, I don't exactly remember the numbers, so those probably aren't correct, but the mean skewed really high because of those really extreme data points. So the examples we'll see today, they're not nearly as extreme as that, but that one is very extreme. Visually, your curve would look more like this, where you've got a really long tail, is what it's called, on one side. It's not even on both sides. Or your whiskers on one side would be much longer. Okay? So now this one is skewed opposite of this one, because the opposite whisker or tail is longer. And then lastly, the mode can be used for non-numerical data. For example, most common car in a parking lot. So say like the Toyota Camry is the most. There's not really much numerical you can do about it other than count up and say, oh, there's 15 Camrys in the parking lot, and call it good. Okay? So there's two ways even further that we can visualize these. The first one we kind of saw a little bit is called a box plot. I guess that's the second one. It can also be called a box and whisker plot, and then there's also a dot plot. So the dot plot uses dots to represent how many items or people represent each categorization. So in this case, Kevin's family is asked how many states they have visited other than their own. So one person has visited 3 other states, 3 people have visited 6, 2 people have visited 7, and 1 person has visited 8 other states, okay? A box and whisker plot has something called a 5-number summary that we use. These include the things on here. We have our minimum, our lower quartile, or Q1, our median, upper quartile, or Q3, and our maximum. And those form that box and whisker plot. So we are going to make a dot plot for the following data set to start. So So Coach Bass was looking to order new jerseys for his baseball team. His players' sizes are below. Which measure of central tendency would be best? So we go ahead, we notice we have a number line. I didn't need to make it nearly that long because all we have is small, medium, large, and extra large shirts. Okay, so now for every shirt that I have, I'm going to put a little dot. So I have a small shirt, cross that out, just so I don't reuse it. 2 mediums, 2 larges, another medium, extra large, large, extra large, medium, and large. Now, because this is a non-numerical data set, I'm going to use my mode, and then I'm just going to ask myself, what is my mode here? And because 2 different shirt sizes show up 4 times, I'm going to say that the mode is medium and large. So there's actually 2 modes. Okay? So that's just a simple dot plot. We are now going to write a 5-number summary and make box plots for the following data sets. So as a basketball player for her school's varsity team, Riley scored the following points in her last 8 games. So this isn't one of our values. It's not an amount of points. It's just saying there's 8 games listed here. So we have those points, and then ask which measure of central tendency would be best. So we have to find the median. That's one of our things in our 5-number summary. So we need to order these from smallest to biggest to start. So I have 12 and 12 and 14 and 16 and 18 and 21 and 21 and then 23. So now that I've ordered them, I can create my 5-number summary, my minimum, my quartile 1, my median, my quartile 3, and my maximum. So my minimum, smallest number, easy, 12. My maximum, biggest number, 23. My median, like our last lesson, we will count in pairs. Notice these are sharing the median spot, so you find the average. That is equal to 17. Now, for Q1 and Q3, this actually isn't hard to find. You just go ahead and you find the median of the medians. So you're going to count off 16 and 12, and then 12 and 14. Now, these are shared for Q1, so once again, you'll find the average of these. And you get 13 for Q1. And then you'll do the same thing on the other side. You'll count off these 2. And then 21 and 21 share for Q3. So the Q3, or quartile 3, or upper quartile, is 21. Okay? So now you can create a box plot. For this 2, we need a number line. So we'll start with that. I'm going to start at 10 and count by 2. Do your best to keep the spacing between your hash marks even, because if you don't, that could throw off what your box plot looks like. So I tried to space them out equally. Then I put either a little dash, like they did above, at my minimum or my maximum, or I can put a little dot. I don't mind either way. Then I draw a longer line for my Q3, a longer line for my median, and a longer line for my Q1, so 13, 17, and 21. And then I enclose those lines into a box. And then I draw in my whiskers. And that is my box plot. Okay? So within a 5-number summary and a box plot, we know that 25% of the data is between the minimum and the lower quartile. We also know between the lower quartile and the median is another 25% of the data. And then between the median and the upper quartile is another 25%. And then between the upper quartile and the maximum is another 25%. So, you could be asked a question that says, what percent of games did Riley score more than 13 points? Well, the ones that she scored more than 13 points would add up to 75% of games. If you were asked, say, what percent of games did Riley score less than 17 points, that would be 50%. So, any box plot, any 5-number summary, you can use this idea to know about the data and how it is spread. So even if you had a really long whisker here, if this was a whisker way out here, that would still just be 25% of the data, just way spread out. And these would be more close together, more condensed. So the last question here, what would be our best measure of central tendency? Well, this would be the mean, because it's all pretty well central. There's not a whisker that sticks out really far, and we can use our mean to find the measure of center. We have another question here, question 2. We have donations were collected for the sports fund. Mr. Wilson was able to collect 8 donations and these amounts. Which measure of central tendency would be best? So once again, we're going to create a 5-number summary. And we are going to create a box plot. So, first things first, order these. I have 10, 20, 54, 100, 106, 165, 184, and 200. So, going to start with my minimum. That is 10. My maximum is 200. I try to find my median. I count in. They are shared again, so I find the average here. This is 103. Then I find my first quartile, which is just the median of the left side. So I find the average here, which is 37 for Q1. And then I count over here. And I find the average of 165 on 184, and I get 174.5 for Q3. So Q1 is 37, Q3 is 174.5, and I can create my box plot. So this one, since we have a pretty big spread between 10 and 200, I'm going to count by tens, and I'm going to go from 10 to 200. Don't know if I gave myself enough room. Gotta extend my line a little bit. Okay, So now I know that my minimum is 10, my maximum is 200, Q1 is 37, Q3 is 174.5, and I know these don't look exact because we have a distance of 10, so we just kind of estimate where we put our lines. Anyway, I finished drawing my box. I connect my whiskers, and then I have my box plot. Now, if you had asked me before I drew this box plot, I probably would have guessed that this data was going to be skewed, because there's some numbers that are 10, very small, and some numbers that are very big, 200. Now, the numbers are all nice and evenly spread out throughout. This means that we can use the mean again. So it's not skewed, which means the mean is a good measure of center. All right, this next problem, we have another dot plot. We have the travel times in minutes for 15 workers in North Carolina. You'll notice that we have something called an outlier here. Most of the data is centered around this area, except for one, which we call an outlier. We are going to begin by finding the median of this data set and then interpret it in context. Now, the easiest way to find the median when already given a dot plot is to just look at the dots and then compare it with the data. So I know this is 5, this dot here is 5, and then these 4 are all 10s, and then I've got a 12, that's what this one is here, I might need to cross-reference, and then a 15, 2 20s, a 25, 2 30s, 2 40s, and a 120. Now I'm going to real quick make sure I do have 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then to find the median, I'll just pair them off. So our median, since it's an odd number of data, is 20. In context, this means that half of the people drive more than 20 minutes, and half of the people drive less than 20 minutes. Okay, so the median tells us that half of your data has less of a drive and half has more of a drive. Now we are going to calculate the mean travel time, and it does say show your work. I'm going to do the bulk of the work on my calculator, and then I'll just show out the total addition. So add them up. And I get 397. And I divide that then by 15, because that's how many data points there are, which is about 26.5 minutes. okay? Then it asks us which measure of center, the median or the mean, describes a typical travel time to work for this sample of workers in North Carolina. Justify your answer. Now, because visually I know that I have this outlier, which kind of skews my data, it makes it not as evenly spread, I would say that the median is a better center because my data is skewed. Okay, if that outlier didn't exist, which is what we're going to talk about now. Oh, this should be a 60, my bad. They're not a 60, a 120. If the outlier of 120 did not exist, what would these numbers be? So we're going to calculate the median and mean if we did not include the outlier of 120. So, pro tip here. Since I'm not going to include 120, I'm just going to take, what was 397, and I'm just going to subtract 120 from that. That's going to help me get my mean, because now I take, 277. Now I have 14 data points, not 15. And then I will divide that by 14. And I get about 19.79. Okay? My median, I'll have to recount here. So let me see. Let me just copy this data down. My median will actually shift as well. So I'll use a different color. This data point we're going to pretend no longer exists. I count them out. I've got these two, these two, these two, and then we've got a shared. When I find the average of these to find my new median, it is now 17.5. And these are actually both minutes. So this has an average of about 19.79 minutes, or a median of 19.79 minutes, or a median of 17.5 minutes. So now the median or the mean would be okay ways to look at this data and use for the measure of center because it's no longer as skewed. Both work. So ask, what can we see about how an outlier impacts both the mean and the median? What implications does this have about when, how they should be used? So we're going to write this out. So the outlier shifts both the mean and the median. Depending on what the data set is, it could change even more than it did. If you think about the ring example I brought up earlier, that would make it change a lot more because you have bigger numbers, like a couple $1 million is bigger than 120 minutes. The mean should be used when the data is normal, and the median is better for skewed. And lastly, in a 5-number summary percent and percentile are two different things. So the question is, in what percentile is the person who drives 25 minutes? Now, we haven't seen this before. We have our data set. I'm going to copy that down again. And we will look at it. So above, we were talking about percents and how you can find like what amount of data is bigger than or smaller than a certain number. But if you were asked for a specific percentile, if you guys ever have kids, they talk about like percentile of height or weight often. There's other percentile things too, but that's just the first one that popped into my head. So to find a percentile, we're going to use the whole data set, not the one without 120. You are going to count how many numbers are smaller than that specific one. So there's 9 numbers smaller than 25. So you're going to take 9 divided by the total amount, which is 15. This will give you a decimal. That is fine. Oops, don't have my calculator up anymore. That's okay. I know that 9 divided by 9 divided by 15 is actually 0.6. And since we're asking for like a percentage, you can either multiply that by 100 or convert to a percent, which means 25 is in the 60th percentile. And that's all I have for you today.